Okay, so today we're going to be solving quadratic equations by factoring. Last time we met, we were factoring, we were practicing factoring. So that is a part of what we're going to do today. And what we're looking at, once we have things factored, we would factor, and you'd have something like x plus 3 times x minus 5. What we're going to do is we're going to have an equation like this down here. And the first thing we have to do is make sure it's equal to 0. Because remember, when we factor, when we solve a quadratic equation, we're looking for the x-intercepts. And remember, x-intercepts have some x value, but the y value is always 0. So if we think of this as y equals this quadratic function, we're looking for where the y value is 0. So the first thing we have to do when we're solving quadratic equations by factoring is make sure that our equation is equal to 0. And once we've done that, we can factor our polynomial just like we were doing last time we met. So don't forget to check for a greatest common factor first. And then once you have factored, then you're going to take each factor, the x plus 3 and the x minus 5 up here, and you're going to set it equal to 0. Just like this, x plus 3 equals 0 or x minus 5 equals 0. And then you've got two really simple equations to solve. So if I were to finish this one up, I would subtract 3 from both sides, and I would get x equals negative 3. And I would add 5 to both sides, and I would get x equals 5. And those would be my two solutions. And that could be negative 3, 0, like this, or 5, 0, like this, or remember you can write them as a solution set. So when you're taking your test, if there is a multiple choice part or on the multiple choice part of your test, remember either of these ways is acceptable. Okay, so if we look at number 1, we have 16x squared plus 8x equals 0. So first thing, make sure it's equal to 0. So here's my equal sign, the 0 is all by itself, so we're good to go. So the next thing we do is we factor. Don't forget to check for a greatest common factor. Remember, a greatest common factor is something that can be factored out of every single term. So we look at the numbers, 16 and 8. Well, I know I can factor an 8 out of those. And then I have an x squared and an x. They both have an x to give away, so our GCF is 8x. So when I factor that out, or remember, divide it out, 16x squared divided by 8x. 16 divided by 8 is 2. X squared divided by x is x. Plus 8x divided by 8x is 1. And remember, it's still equal to 0. So remember, we look at our stuff in the parentheses and we ask ourselves, can I factor this any further? And remember, when we were factoring last week, we were looking for things that had a squared here. Remember, it had to have an x squared to be able to factor it any further. So my factors, and it doesn't have one, so my factors are 8x and 2x plus 1. So we take our factors of 8x and 2x plus 1, and we set them equal to 0. And then the last step is to solve. So if I solve 8x equals 0, that's just a simple equation. We divide by 8, and x equals 0 divided by 8 is 0. Here, we subtract 1, and we get 2x equals negative 1. And then we divide by 2, and x equals negative 1/2. So my solutions, again, can be written as coordinate pairs as x-intercepts, or they can be written as a solution set, negative 1/2, 0. Please, please remember, we are still solving quadratic equations, and we are still finding the zeros. Okay, we are finding the zeros. Zero product property, we're finding x-intercepts. These are the zeros, okay? All right, let's go on to number 2. Number 2, we have x squared equals 64. Now, first thing we check, is it equal to 0? And it is not. So here's the thing you want to remember. I've got to get this equal to 0. I always want my x squared term to have a positive coefficient. So right now I have a positive 1 there. So I'm going to leave it alone and I'm going to move the 64. So I'm going to subtract 64 from both sides. So that will give me x squared minus 64 equals 0. Okay, remember that these are not like terms, so I cannot combine them. Now I have an x squared minus 64, so I'm ready to factor because it's equal to 0. So when I'm ready to factor, we first check for greatest common factor. I have x squared and 64. There's no GCF there. But please remember, my middle term is going to be 0. Or you could recognize this as a difference of two squares. X squared is a square, 64 is a perfect square of 8. If you didn't recognize that, go ahead and list out your factors for 64. Remember 1 and 64, 2 and 32, 3 doesn't go into it, 4 and 16, 5 doesn't go in, 6 doesn't go in, 7 doesn't go into it, and it would be 8 times 8. And then we're coming back up on this side. Now remember, if we want our middle term to be 0, when we undo FOIL to factor, x squared, we get x times x. 64, if I want to make 0 in the middle, I have to use the 8 and the 8. Remember, that's going to make an outer of 8x and an inner of 8x. And in order to make 0, one's positive, one is negative. And it's still equal to 0 over here. So x times x is x squared. Negative 8x plus 8x is 0x. 8 times negative 8 is negative 64. So my factors are x plus 8 and x minus 8. So I'm going to take each of those and set them equal to 0. And then we're solving a simple equation. So to solve for x here, I would subtract 8 from both sides. And we get x equals negative 8. Over here, I would add 8 to both sides. And we get x equals 8. So my two solutions, my two places where it crosses the x-axis, where that parabola crosses the x-axis, are at negative 8 and 8. So please remember, big picture. I've got one crossing at 8, 0 and negative 8, 0. So don't forget, big picture, what we're doing here. Okay, so your parabola would go through something like that. Okay, all right, let's move on down to number 3. On number 3, we have 27x squared plus 5 equals 48x. So again, you ask yourself, is it equal to 0? So when I look at this, it is not equal to 0. It's 27x squared plus 5 is equal to 48x. So again, check your x squared. I want it to be positive. Please remember, when we're factoring, we want that first term to be positive. And it is positive. It's a positive 27x squared. So that means I'm going to get rid of the 48x. We're going to do that by subtracting 48x from both sides. And that will make that 27x squared. Negative 48x does not have a like term over here, but remember we put it in order. X squared, x, and then your constant, plus 5. And now it's equal to 0. And so the next step that we take is to factor. So we look at for our greatest common factor. 27x squared, negative 48x, and 5 don't have a number or a variable that will divide out of every single one of those. So I'm going to go ahead and undo FOIL. So 5 is prime, so I know I'm going to have 1 and 5 here. 27, however, is not prime, so I'm going to list my factors for 27. 1 and 27, 2 doesn't go into it, 3 times 9, 4 doesn't go into it, 5 doesn't go into it, 6 does not go into 27, 7 does not go into 27, and 8 does not go into 27. And then I'm back to 9. So I know I'm going to have to use one of these two factors. So I need to make 48. So when I look at this, I know if I multiply 9x times my outer 5, that would give me 45x. And if I put my 3x here, that would give me 45x and 3x. And I can make that be negative 48 by putting both of them negative. So negative 45x plus negative 3x is negative 48x. So that works. So double check. 9x times 3x is 27x squared. 9x times negative 5 is negative 45x. Negative 1 times 3x is negative 3x. When I combine those, I get negative 48x. Negative 1 times negative 5 is positive 5. So now I have it factored. Once we have it factored, again, we put our factors equal to 0. My factors are 9x minus 1, so I set it equal to 0, and 3x minus 5, so I make that equal to 0. And then we solve each simple equation. So when I do that, I'm going to add 1 to both sides here, and I get 9x equals 1. Then I'm going to divide by 9, and x equals, I can leave that as a fraction of 1/9. It is already reduced. So then over here, to solve this one, first we would add 5. So 3x equals 5. Next, we solve for x by dividing by 3. So 1x is equal to, again, you can leave that as an improper fraction. And so x is equal to 1/9 or 5/3. Again, please remember, big picture. Those are the zeros of the function. So 1/9 0 is where it crosses the x-axis. 5/3 0 as a coordinate pair is where it crosses the x-axis. Okay, last one, number 4. The height of a javelin in feet is modeled by h of t equals negative 16t squared plus 79t plus 5, where t is the time in seconds after the javelin is thrown. So remember, the height of the javelin is the h of t. How long is it in the air? So think about this. If somebody throws a javelin, how long is it in the air? It's going to be when it hits the ground again. So over here, I want to know what the time is when my height is at 0. Okay? So again, I'm plugging 0 in for h of t equals negative 16t squared plus 79t plus 5. Okay? Now remember I said I wanted this, at the squared term, my quadratic term, to be positive. So the first thing I'm going to do to fix that, because when I look at this, 16, 79, and 5, there is no GCF there, and I have a t squared of t, but I don't have a t here. So to fix that problem, I'm going to have 0 equals, and I'm going to factor out a negative 1. So when I do that, it just changes the sign of everything. So that's 16t squared minus 79t minus 5. And then I can factor that. So 0 equals negative 1, and then we're going to put that into its binomial factors. Again, 5 is prime, so I know factors have to be 5 and 1. And then I'm going to go over here and list my factors for 16. I know I have 1 and 16, 2 and 8, 3 does not go into it, and 4 and 4. So if I'm going to make 79, I have to look at my possibilities. Okay? So if I look at these down here, this would give me 20 and 4. That's not going to work. 8 times 5 would give me 40 and 2. That's not going to work. So I'm going to have to do 16 and 1. Okay, 16 times 5. If you work that out really quickly, 6 times 5 is 30. 5 plus 3 is 80. So 6t plus 16t and then 1t here. My outer would be 80t. My inner would be 1t. So in order to make negative